Hello, welcome to the Tekla TEDDS course. Okay, in this part, we're going to be performing a column design, to British standard. Okay, so I'll make sure that my United Kingdom is selected here. All right, I'll go to new. All right, so I'll go to columns. All right, I'm going to be using RC column to BS8110. Click on it. Okay, so I'm going to be starting with this. I can start from scratch, okay, or I can start from brief short column example. Okay, let's start from scratch. Calculate. All right, so here we have to define all the details. So we are going to be using an example problem. Okay, so if you come here, all right, so this is our example problem. Okay, so we have a 275 squared column. Okay, so we're going to be using, there are two examples. We're going to be using this B, an ultimate axial load of 1 to 80, okay, and a bending moment of 35 about the major axis and 25 about the minor axis. The concrete grade is 30, the reinforcement is 500, and the cover is 35. Okay, the length of the column is 4500 mm. Okay, so I'll come back here. I'll start with the scope. All right, so it's going to be a brace column. Okay, as said in the example. Okay, it's a short brace column. All right, so there's moment about the major and the minor axis. Okay, no shear, no crack width. Okay, I'll click on OK. I'll go to geometry. All right, the column is 225 squared, sorry, 275 squared. All right, the height is 4500. All right, I'll click on OK. I'll go to the reinforcement. So if I come back here, all right, so this is the result for the design. Okay, there isn't H25 and links of 8 are 275 spacing. Let's try it. Let's see if that their provision will pass. Okay, so I'll come here, I'll choose 25 so I need 2 reinforcement in each face. Okay, 2 reinforcement in each face. That means, all right, I have 2 reinforcement here, 2 reinforcement here, 2 reinforcement here, and 2 reinforcement here. Okay, and the size of the reinforcement is, I think, 8. All right, let me go back to the problem. Okay, that's H8, correct. So number of links is 1. Okay, the spacing of my link is 275. I'll select 275. Now my nominal cover is if I come back here, is 35. Okay, so I'll come back here. Okay, 35, and minimum reinforcement is 0.4%, correct. I'll click on OK. All right, so I'll go to materials. My concrete grade is 30 and 500. So I'll come here, select 30. Here's already 500. The factor of safety according to Eurocode, according to British standard are here. Okay, so sometimes you may like to use a 1.05. Okay, instead of 1.15, you can change it here. Click on OK. So the next thing is to go for the loading. All right, so if I come back to the problem, I have 1 to 80, 35, and 25. Okay, so the axial force is 1 to 80. The moment about the major axis is 35, and about the minor axis is 25. Click on OK. All right, so you can see the design has been done. Okay, so the axial load applied is 1 to 80, and resistance is also 1 to 80, which is almost a perfect design. Okay, while the moment resistance is 53 and applied is 43, which is also a very good design, 0.8 utilization ratio. Okay, so we did not perform any shear check. Okay, so I'll just click on include sketch. Okay, I need the sketch of this column in the report. I'll click on finish. All right, so this is my column design. Okay, it passed. So this is the column definition. This is the size. Okay, this is the reinforcement and the concrete grades. If I come down, this is the length, this is the slenderness limit 60 times B, okay, which is okay. All right, this is the brace column check, okay, about the major and minor axis is within limit, okay, it's 12 point something, less than 15. All right, so this is the ultimate loading on the column as we defined. All right, so this is the minimum design moment, okay, calculated by using 0.05 h, okay, or 20, whichever is the least. All right, this is the minimum moments is less than our moment, so we're going to go to our moment. Okay, so on and so forth. We can just go through all the calculations. Okay, it's done correctly, properly, according to the code of practice. So you can just go through all of them, okay, up till where the reinforcement is determined. Okay, all right, this is the design moment and this is the axial load. Okay, with this now we can get the area of concrete. All right, so with that now we can get the area of reinforcement. Okay, so we are using 0.4% as minimum reinforcement, minimum percentage of compression reinforcement. Okay, so minimum steel area is 303, while maximum steel area is 4,538, and our steel area is 1,963, which is perfect. Okay, so area of compression still provided is okay. All right, so the minimum containment steel, okay, is 8 at 275 is also okay because the spacing is less than 300, okay, and the minimum reinforcement is 6.3, okay, and we're using 8, which is also perfect. So the design has been done perfectly and accurately, okay. By just providing simple inputs, okay, we get a detailed professional calculation sheet. Okay, so this brings us to the end of this part. Thank you.